Hello friends, today we will see the product of matrices or multiplication of matrices. How to do, how to find a product whenever two matrices is given. So the main condition to be met before finding out the product is to check whether the product, if you want to find the product of A and B, matrix A and B, you need to check whether the product AB is defined. What do you mean by defined? If you want to check whether it is defined, then first see what is the order of matrix A. Say in general, if I say order m by n and matrix B is of order, should be of the order n by p. That means what does it say is number of columns of matrix A should be equal to number of rows in second matrix. If this is equal, then only that product is defined and that is of the order matrix AB is of the order m by p. For example, if matrix A is of the order 3 by 4, then B is of order, should be of the order 4 by that n. This can be anything, 4 by say 2. Then only you can say product AB is defined, since number of columns of matrix A is equal to number of rows of matrix B and the order of the product AB is 3 by 2. So this is how we can multiply the matrices. So how to multiply? Once you know whether the product is defined, then you should multiply those two matrices. So first we should see how to multiply any of the two matrices. So what you need to do is first write down the given matrix. So suppose A is given. If you want to find AB, so how will you write? A is given as 6, 9, 2, 3 and B is 2, 6, 0, 7, 9, 8. That means here you need to check whether it is defined. So order of A is 2 by 2 and order of B is 2 rows and 3 columns. Since this column and row of second matrix is equal, AB is defined. Hence you can go for multiplication. So first and foremost step is what you need to do is first multiply the first row of the matrix A. This is the first row. Multiply it with the first column of matrix B. Say it will be of 6 into 9, which will be 6. The 6 should be multiplied by 2. That means first row first element should be multiplied by first column first element. So it will be 6 into 2 plus second row second element, first row second element and first row second element should be multiplied. So these two should be added together. This will be in one. Similarly, multiply first row with second column. Okay, this should be multiplied with second column of the matrix like this, and which will be written in the second column. So it will become 6, 6 are 36, which will be 6, 6 are 36, that is 6 into 6 plus 9 into 9. Okay, this will be in the second column. And for the third column, what you need to do is you have to multiply first row with third column, and that you need to write in the third column. So here you will be having 6 into 0 plus 9 into 8. So here we complete first row. Okay, now similarly come to second row of the first matrix. Second row is this one. So second row is 2 and 3. Similarly, how we did for the first row, similarly do it. So first you need to multiply here 2 into 2 plus 3 into 7. Again second, this element is multiplied with this and this and then added up. So it will be 2 into 6 plus 3 into 9. Similarly, it will be 2 into 0 plus 3 into 8. So what you will get? 6 2s are 12. 12 plus 63 will be 75. Again 36 and 81. So what is 36 and 81? It is 117. Similarly, 6 zeros are 0, 9 sevens are 72. And 4 plus 21 is 25. 12 plus 27 will be 39, and here it will be 24. So this is how you need to multiply any two given matrix. And you should see that one more rule, commutative. As you know what is commutative, that is AB is equal to BA. But which will not hold good for all matrix, because sometimes this product AB may be defined, but when you see BA, it may not be defined, or even if you if it is defined, the order will be changed. So when the order is changed completely, it will be not equal. So in this case, let's check. So AB is of the order what? You got it as 2 by 3. Similarly, we got 2 rows and 3 columns. If we have to find BA, what will be the thing? B means write the matrix B first, multiply it with A. So order of B is 2 by 3 and order of A is 2 by 2. Since this is not equal to this, 3 is not equal to 2, therefore BA is not defined. Hence you can say AB is not equal to, you cannot multiply BA, so it is not commutative. So it need not be that always any two matrix is defined to be commutative. So you need to multiply and check if the order is also same, then you need to check, see the each value is similar to the next product. Suppose AB is this, BA, if you get same order also, you need to check the value, then only you can say it is commutative. So that is commutative law. So you need to check for each and every problem. We cannot generalize the rule. Next is zero matrix. Zero matrix is as the product of two non-zero matrices. We know that for real numbers AB, if AB equal to 0, then either A or B equal to 0. That is true. Suppose if you have to get any product to be 0, then either it should be 4 into 0 or 0 into 3. That means either A or B should be equal to 0. Then only you get the product of that numbers as 0. But it is not the same in the case of matrix. See, here in this case, let's take an example. Here AB is 2 matrix, where these two are not 0 matrix. As you all know what is 0 matrix, all elements should be 0. Here it is not a 0 matrix. So let's check whether we will get the product to be a 0 matrix. So order is 2 by 2. Order of B is also 2 by 2. Hence product AB is defined. So how to multiply? So here it will be 0 minus 1 2. B is 3 is 5 0 0. So when you multiply, what happens? First row into first column. So that will be 0 into 3 is 0 plus 1 minus 1 into 0 is 0. Again first row is multiplied by second column. So it will be 0 plus minus 1 into 0. Again it is 0. Second this one here again it will be 0 into 3 is 0 plus 0 into 2 is 0. Again second row with second column it will be 0 into 5 is 0 plus 0 into 2 is 0. So that will be equal to 0 0 0, which is a 0 matrix. So even though the two individual matrix is not a 0 matrix, the product can be a 0 matrix, which is a bit different when compared to product of real numbers. Let's check out the properties of multiplication of matrix. The multiplication of matrix possesses the following properties, which we state without proof. First one is associative law. Suppose for any three matrix, say A, B and C, we can say if both the sides of the equality are defined. That means if the product AB into C, AB is defined and AB into C, this is also defined. Again on the this side again this product is also defined, then you can say AB into C will be equal to A into BC. So that is applicable only when the product is defined. Distributive law. If you have any three matrix, then A into B plus C will be equal to AB plus AC. And similarly, A plus B into C will be equal to AC plus BC only when on both the sides the product should be defined. Next is existence of multiplicative identity. For every square matrix A, there exists an identity matrix of same order such that IA into AI is equal to A. That means whenever you multiply any matrix with the identity matrix, even if you change the order, like I into A or is equal to A into I will be the same matrix. But one condition is that the identity matrix also should be of the same order. So this is the properties of the multiplication of matrix.